Hello, everyone, and welcome to the World of Genetics. Today, the topic of discussion is the adaptive hypothesis. This theory was used by Francis Crick to propose the function of the tRNA in the cell. Before we move further, let's go over the definition of an adapter. An adapter is defined as something that acts as an intermediate to connect things that aren't normally found together. For an example, a plug or a bridge. Before we move further, let's go over mRNA and tRNA. mRNA is messenger RNA and it is molecules that carry the coding sequences for protein synthesis. And tRNA is for transfer RNA, and these molecules carry amino acids to the ribosome during protein synthesis. One tRNA can pair with more than one codon due to the adapter. There are 61 codons that code for amino acids, but only 31 to 41 different tRNA molecules. Having a varying third codon can still give you the same amino acid. tRNA molecules contain anticodons, which are complementary to the molecules of the mRNA. Let's have a visual for this. If the mRNA has GCA, then the tRNA will have CGU, which will code for arginine. And let's have an example side by side. The mRNA is still GCA, and the tRNA for this one is CGG, which is still codes for arginine, as you can see. Ribosomes contain three sites that hold tRNAs. You have the A site, which is aminosyl, P site, which is peptidyl, and the E site, which is the exit. Now is discussion time. What could prevent a tRNA from acting as an adapter that follows the universal code? One scenario could be adding a stop codon to the P site of the tRNA. Let's have the mRNA be AUG and the tRNA is UAC. The amino acid that will be coded is tyrosine. Now let's have the mutation take place, and this will form the tRNA into a stop codon. The type of mutation that is found in this situation is a missense, a point, and a transversion. The tRNA after mutation would be UAG to make it stop. As you can see, after the mutation would take place, no amino acid is encoded, and it lets the ribosome pause and allow it to leave the mRNA. If this was to happen, the tRNA would not be able to bind to the mRNA, and the polypeptide chain will be cut short. One thing to also note is that protein synthesis would not be able to happen properly because of this stop codon being so early on, and this would cause the cell to not be able to use metabolism because that's what the proteins are for, and it would not be able to do a lot of cellular functions that the proteins are needed for, and this can cause the cell to be negatively affected, and it can cause it to not develop like it should, and eventually it could die off and cause the individual harm. I hope you really enjoyed today's lesson. I hope you come back for many more. Thank you.